For this, we will draw the table. Right? We will verify everything. We will not take everything for granted. Right? So we will verify whether it is really a counter or not. So what are my outputs here? Q3, Q2, and Q1. Right? And my input is clock. So initially we will assume the outputs are all zeros. So if Q1 is 0, then QB is equal to 1. So my B1 will be 1, but it won't go inside D flip flop until I apply the clock, right? So when I apply the clock, then when I apply the clock, when I apply the rising edge of the clock, then my B1 will go inside the D flip flop and it will arrive to Q1, right? So when clock is equals to 1, then Q1 will change to 1. And what happened to Q2? The clock of Q2 is not yet changed because it is depending on Q1's output, right? So it will be 0. So in next clock, when clock is equal to 2, then this will go as a clock and the Q2 will also change. By that time, if you remember, the output of Q1 is 1. So the QB1 is 0 and this will go as 0, right? So in this way, if you draw the table for remaining clock pulses, it will look like this: 100, 5101, 6110, and 7111. See, this is simply representing the Boolean numbers, right? I mean, the state of Q3, Q2, Q1 will give me what is the number of clocks that are applied to this circuit, right? That is how we can design a counter using a 3 D flip flops, right? Yes. So what is the other application of D flip flop? An event detector. It is very simple. You have a D flip flop. What is the purpose of D flip flop? The D flip flop data will only change when there is a clock is arrived. So in other words, you can say the data will only flip when there is an event is happening at clock signal. So directly connect that event to the clock. Simple. If you want to have an event like switch on the fan, connect the event to clock, then the Q will be 1 whenever there is a clock, right? This is one of the application of D flip flop. And other application is data synchronizer. This is very, very important. What are data synchronizers? Data synchronizers are very essential blocks in any communication devices or any kind of devices where the data synchronization is required. Why the synchronization is required? Because let's say you have a circuit like this, and one of the input is coming directly from flip flop and other input is coming from very big combinational circuit. Okay, let's take an example. This path is having 100 nanoseconds delay and this path is having only 10 nanoseconds delay, but I want these two paths should appear at the same time. So how can I do that? This is what synchronization means. I want to have a synchronization in these two paths. How can I do that? By using a simple D flip flops. See, I have a combination circuit which is having n inputs and two outputs. So this A and B are arriving with different path delays. Let's say here maybe only two inverters are there and maybe here I have, let's say, 100 inverters are there. So obviously the path delay of this is small compared to path delay of this, right? So in that case, A is arriving at, let's say, 10 nanosecond and B is arriving at, let's say, 300 nanoseconds. So what will happen? If I want both A and B should work together, then I need to have a data synchronizer and then I need to apply them to my next stage output like this. If the A is coming at 10 nanoseconds and B is coming at, let's say, 100 nanoseconds, and I want both of them to be having output at same time, what I can do? I can connect them to D flip flops. What is the purpose of D flip flop? It will only give me the output whenever there is a clock is assigned. So what I will do? I will connect the clock of these two D flip flop to a single clock. So now see what happens. The output of A, even though it is arriving at 10 nanosecond, it won't change until the clock arrives. So, the output is depending on clock input but not the A input, right? So when I apply the clock, then only the A will go to the next stage, which I want here. And similarly, when I apply the clock, then only the B will go here. So in this case, what I will do, I will apply my clock after I know that A and B are arrived. After arriving A and B, then I will apply the clock. Then I will get A and B at the same time, right? This is how I synchronize my data. Simple, right? One more application of D flip-flop is a frequency divider. What is a frequency divider? Let's say you have a frequency of 500 megahertz and you don't want that high frequency signal. You want a frequency of only 250 megahertz. How can you achieve that? How can you divide the frequency of a clock signal? So the frequency is 500 megahertz means 500 megahertz means the time period will be very small, right? And frequency of 250 megahertz will have time period of double of this, right? So this is a signal with frequency of 250 megahertz. So how do I get a frequency divider using a simple D flip flop? Connect the D flip flop in this fashion. Give the D input through QB output. Let's see what will happen. Initially, let's assume the Q is 0. If the Q is 0, then QB will be 1, right? So 1 will appear here and it won't change until I apply the clock. So when clock is applied, the 1 will go to Q, right? So you see the QB is changing, the QB is getting propagated to Q whenever there is a application of clock, right? So whenever there is a positive edge of clock like this, then my data is flipping from one state to other state. You understand what is happening? Whenever there is a positive edge is coming, this is the clock signal, then my data is flipping from 1 to 0, 1 to 0. So this is how we achieved a frequency divider. This is a high frequency signal and this is a low frequency signal. So we'll see what is a JK flip flop, right? In JK flip flop, we have three inputs J, K, and clock, and we have two outputs Q and QB. The symbol looks similar. We have inputs J, K, clock, and output Q and QB. And the characteristic table of JK flip flop is like this. If both J and K are 0 and 0, then output should stay in the same state. And if J is 0 and K is 1, it is reset to 0. And J is 1 and K is 0, it is set to 1. And this is interesting, when J and K both are 1, it should be complement of Q. In the case of SR flip flop, it is an indeterminate state, but in the case of JK flip flop, we want that to be a complement. So there is one more flip flop called T flip flop, which is called toggle flip flop. Okay, what is its purpose? Whatever the data that is coming here, it should toggle here. So how do we achieve that? When Q is equal to, when T is equal to 0, then it should stay in same state. When T is equal to 1, then the data should flip or complement. This is the characteristic table of T flip flop. I am not explaining JK and T flip flop. You can study, or we will explain this maybe in while designing using Verilog. Okay. So with this, we will come to the conclusion. The sequential circuit. What is a sequential circuit? It is just a combination of it is just a interconnection of combination circuit with some memory elements like flip flops. So this is the schematic of D flip flop. There are a lot of sequential circuits. We will explain these in coming sessions. Thank you.